Hello everyone, this is going to be our final exam review for our summer class. All right, so we're heading towards the end here. So this is really going to be the final video that we have for the final exam for our class. So in addition to watching this video, a really good way for studying for the final exam is going to be completing that final exam review assignment. Working on it is going to be great, but completing it will definitely get you kind of really, really ready for that final exam, in addition to watching this video. Watching this video, all the problems that we go over are going to be very important for you. Final exam, as a hint. So there we have it. All the problems you see in this video will be important to you in the near future. If you watch this video and you work on the review assignment and you still feel like some of the information is still a little fuzzy, please feel free to email me and we can go over some things before the final exam. So, all right, without further ado, here we are with our final exam review, and good luck.
So we're going to do problems in our review today. In addition to the problems that we do go over in the review, it's also helpful to review these items on your own. So we're going to go through the different items from each chapter that are going to be the most important for you to study up on for the final exam. So from chapter 6, we have finding the radius, arc length, or central angle for circles if you're given 2 out of the 3, and just finding them in general. It's going to be important, so knowing those equations. That's from section 6.1. Finding exact values of trig functions, that'll be from section 6.3. Graphing trig functions will be section 6.4 and 6.5. And solving applications involving sine or cosine functions, that'll be chapter 6.4. So for every important key point, the section is also labeled within the chapter that we're looking at. So we're looking at chapter 6. All of these points have the corresponding section that they're found in. Sorry, I'm coughing a little. Chapter 7, we have solving equations with inverse trig functions, so section 7.1. Solving equations with more than one trig expression, section 7.3. Establishing trigonometric identities, section 7.4. And using the double angle or half angle formulas, which is section 7.6. Chapter 8, solving for SAA, ASA, SSA, SAS, or SSS triangles for all cases. Cases being 8.2 and 8.3. So these are all the different triangles that we looked at, whether or not we use the law of sines or law of cosines in solving them. This is all of them together wrapped in one. Then we have using the law of sines and the law of cosines, which are in sections 8.2 and 8.3. And then finding the areas of triangles, which is in section 8.4. Chapter 9, we have converting between polar coordinates and rectangular coordinates, which are from section 9.1. We have converting complex equations to polar, exponential, or rectangular form from section 9.3. Finding vectors from direction and magnitude. So if you're given the direction and magnitude, finding a vector, which is from section 9.4. Finding a position vector given an initial point and a terminal point, which is also section 9.4. Chapter 10, so this chapter 10 and chapter 11, this is 50% of your exam. Everything we just went over is going to be the other 50%. So chapter 10, finding the equation of an ellipse using the given information, which is from section 10.3. Analyzing and graphing ellipses, also analyzing and graphing hyperbolas. Ellipses are from 10.3 and hyperbolas are in 10.4. Graphing parametric equations and finding equivalent rectangular equations, that's from section 10.7. And finding parametric equations for curves from rectangular equations, which is also from chapter 10.7. And then lastly, chapter 11, we have identifying whether a rational expression is proper or not, and then rewriting it if it's not, which is 11.5. And then the big chunk of chapter 11 or section 11.5 was finding partial fraction decompositions. That was the main part of chapter 11 with the one section that we actually did from chapter 11. So section 11.5, that one chapter that we did, that is mostly going to be on partial fraction decompositions. So in addition to everything that we went over. The best ways I can advise you to study would just be to going over lectures, definitely watching this video, going through old exams, and definitely going through old reviews. Probably going through the old review videos and notes are probably going to be one of the best. This also being one of the best ways to study, and then going through old materials will be beneficial as well. Knowing vocabulary and equations is another thing that will be very helpful to you when taking the exam. So knowing what you're being asked and actually having the equations for certain things will be very helpful to know when doing these problems. So, all right, let's get started on our actual review problems. So number one, we have from chapter 6. As a reference, we'll do one problem from each chapter, and then 2 problems from chapter 10 and chapter 11. So our problem from chapter 6, we want to find the missing quantity where S is the length of the arc of a circle and R is the radius subtended by the central angle theta. So we're given the value of theta and we're given the value of S. We have theta is equal to 1/4 radians and S is equal to 5 feet, and we want to find the radius. So in this case, what's going on is that we're given our central angle and we're given our length of the arc of a circle, and now we need to find our missing element, which is the radius. So we can say that for a circle of radius r, a central angle theta which is in radians, subtends an arc whose length is going to be S equal to R times theta. And that's a multiplication and a period. So we have our equation, S is equal to R times theta. So we want to find the radius. So since we want to find the radius, we just need to rewrite this equation. And when we rewrite our equation, we end up getting that R is going to be equal to S divided by theta. And we know the values of S and theta, so we just need to plug them in. Remember, we had that S was equal to 5 and theta was equal to 1/4. So our radius is going to be equal to 5 divided by 1/4, which is the same thing as 5 times 4, which gives us our answer of 20 feet. So summing this up, we get that thus the radius is R equaling to 20 feet. And there's our answer. So knowing how to solve this problem was definitely straightforward, but knowing the vocabulary of what we're being asked and knowing the equation of S is equal to R times theta is what allowed us to work this problem out just as we did already. So knowing vocabulary and knowing equations is going to be an immense help when doing problems. All right, so chapter 7, number 2, we have that we want to show that sine to the power of 4 theta is equal to 3/8 minus 1/2 cosine of 2 theta plus 1/8 cosine of 4 theta. So first thing you want to do is you want to recognize that we're solving an identity. So we're solving an identity here. We're stating that one trigonometric function is equal to another much longer trigonometric expression. So we're solving an identity here. And remember, when we're solving an identity, we want to pick a side to start, and our other side will be our goal. Normally, what we do is we pick the messier side to be where we start, and then our simple side to be where we end up, and that's our goal. In this case, our messy side is so messy that it's easier to start on the simple side. So we're actually going to start at sine to the power of 4 theta. And our goal is going to end up being 3/8 minus 1/2 cosine of 2 theta plus 1/8 cosine of 4 theta. So if we want to start at sine to the power of 4 times theta, we can go ahead and expand this. So we can just say starting with sine to the power of 4 theta. We're going to rewrite this because we know that we have lots of equations for sine squared of theta. And sine squared of, or sine to the power of 4th of theta is the same thing as sine squared of theta squared. So we're going to rewrite this as sine squared of theta squared. So now we can do a lot with our sine squared of theta. So what we're going to end up picking, and what can give us a hint, is that in our answer we have cosines of 2 theta and cosines of 4 theta, which is telling us that it would be helpful if we use a double angle formula here. So we can rewrite sine squared of theta to go ahead and be equal to 1 minus cosine of 2 theta divided by 2. So replacing this, we end up with 1 minus cosine of 2 theta divided by 2 squared, which we can then solve, so we get rid of the squared. And when we do, we are squaring 1 minus cosine of 2 theta. So what we end up getting is 1 minus 2 times cosine of 2 theta plus cosine squared of 2 theta. And this is all over 2 squared. So this will be 4. So now we have this new equation. We're going to simplify it just a little bit more. We're going to go ahead and we are going to divide each term by 4 and have it separated out, since we see that our answer here is definitely separated out with all of our different denominators. So let's go ahead and write this out. So this is going to end up giving us 1 over 4 minus 2 cosine of 2 theta over 4, which is just going to be 1/2 cosine 2 theta, plus 1/4 cosine squared of 2 theta. So we have cosine of, or we have negative 1/2 cosine of 2 theta, which that is part of our goal. So that part can stay the same. But the parts that we see here that are different are going to be our 1/4. We know that it looks like it has to be at 3/8. And our 1/4 cosine squared of 2 theta should end up looking like 1/8 cosine of 4 theta. So we're going to end up replacing cosine squared of 2 theta. So now we can replace cosine squared of 2 theta with 1 plus cosine of 2 theta divided by 2. So we're using our double angle formula again and plugging this in. So we still have 1/4 minus 1/2 cosine of 2 theta. Plus, and now we have 1/4 times 1 plus cosine of 2. And remember, we're not just dealing with theta, we have 2 theta. So when we write this out, it's really going to be 2 times 2 theta. So we have 2 times 2 theta divided by 2. And when we simplify this out, we'll get 1/4 minus 1/2 times cosine of 2 theta plus, and this is going to turn into 1/8 plus 1/8 cosine of 2 times theta, which is going to be 4 theta. So we've run out of room here. Our last piece of simplification is just going to be adding our 1/4 and our 1/8. When we add those together, that's going to end up giving us 3/8. So putting this back together, and we know that we started with sine to the power 4 theta. So we have established our identity. And there we have it. So when we were establishing this identity, really the only thing that we did was we replaced a lot of different pieces of this equation with our double angle formula. So we replaced sine squared of theta with our double angle formula, and then we replaced cosine squared of 2 theta with our double angle formula again, and that allowed us to get to our identity. Just a quick note about the last problem. While we did use our double angle formula, you could very easily do this problem again with a half angle formula with alterations. Of course, you probably wouldn't have sine to the power of 4 theta, but you can also establish identities using half angle formulas, not just double angle formulas. So when studying, make sure to go over both.